Hello and good afternoon to everyone. Thank you for attending today's uh, TOA Sound Academy webinar. My name is Keith. I will be the one handling the session for today, uh, tackling the topic of SIP, Session Initiation Protocol uh, for Dummies. The, the topics for today. First, we'll need to establish why SIP is relevant. Why is it necessary to understand and what is it for, essentially. Then we'll discuss how SIP and VoIP overlap but are essentially different from each other. And then next is we'll go through how SIP works. What is SIP? How is it related to our modern day and how it works in the IP domain? The components of SIP, and we'll run through how SIP works in action, just a general overview of how the commands and structures of the servers and the individual devices work. And then finally, I will go through a quick setup on how one can set up equipment, say from TOA, on a current SIP system. Before anything, there are necessary understandings and knowledge that we need to have for SIP, because SIP works on the IP realm, the realm of IP. It requires knowledge of IP addressing. So IP is the way the internet knows where you are and what your device is. It's like your address. That's the name, IP address. And there's two flavors to it: IPv4, which is the older one, and IPv6. For the purpose of our discussion, we'll limit ourselves to IPv4, which is slowly being replaced by IPv6, but not in the near future. Also, another thing to understand is the difference between public and IP addresses. So when the internet was first made, we allocated a system for addresses for about a couple billion addresses for people to use. Unfortunately, as the internet expanded exponentially, we quickly ran out of IP addresses to use for individual devices. So what we ended up doing is the standards for public IP addresses was split to public and private. So that's why you see these 192.168.0.0 XXX IP addresses when you log into your router. Those are actually local IP addresses. They're not seen by the wider internet. That's only seen locally. There's three classes: C, B, and A, related to the size of each local private addresses. And then the router does the hopping on how your local devices see the wider internet. We'll not go into much detail into that. That's just the basic overview of that topic. Another important prerequisite for SIP, because sometimes you'll encounter in your installations local networks that have subnetting. Essentially, they're split into subnets. That's what they're called. Basically, groups of equipments that are categorically isolated from each other in the IP or the LAN network. Finally, ports and sockets is an important topic or thing that you need to understand. A basic overview of it is like, if you think of your IP as the address to your apartment complex, then the socket is the unit number for each individual apartment. In order that, because if you think about it, say your computer has multiple programs working on it, and they're all using the same entry point, same IP address. So how does the system know what data goes to what program? This is what socket is for. And then finally, domain name is the way we've simplified IP addresses. So instead of remembering numbers, we use names instead. So instead of remembering the IP number 216.58.216.238, which is a mouthful to remember. We just remember www.google.com. SIP. Perhaps over the past 10 years, you've noticed a slow movement of the AV industry towards the use of IP. We've used the networks, switches as a backbone for distribution and communication. And of course, we've also used the wider internet for that. For communication applications, we need someone to handle the operator switchboard. So in the olden days of the telephone, they had numbers tied to your local telephone line, and you had a central office where the switching happens so that when you call a number, you're directed to the appropriate endpoint so that you can call them. This is kind of the idea of SIP, but for the IP domain. So the purpose of SIP is to facilitate that establishment of communication. Thus, it's called Session Initiation Protocol. It's automated, all done in programs, and it works in the background of most telephony these days. Speaking of telephony, VoIP is another term that's often confused with SIP. So what is the difference between the two? VoIP is a broad term describing the telephony that is being implemented in IP. Instead of an analog telephone system, VoIP is the term that is kind of the corresponding thing for that in the IP domain. It's like it's called voice over IP. SIP in particular is sort of like the transmission in your car. It fulfills the operation of the operator to connect one endpoint to another. Some VoIP systems may use SIP for that functionality, or they may use other things. More often than not, you will see that VoIP systems do utilize SIP. I would say about 95% of the time. Rarely have I seen any VoIP system that do not use SIP at all. I would say even 99% if I may hazard a guess. So again, if VoIP is the car, SIP is the transmission of that car. A car, say Dodge, may use a different transmission, say from Jatco or a different company, but more often than not, they would use one particular transmission that is useful for them and is widely supported, which what SIP brings to the table. Excuse me. So, as I've said before, SIP is designed to accomplish the task of a switchboard operator. It's used to set up, modify, and terminate connections between endpoints, which are properly called user agents. These are desktop phones. They may be software apps installed on your phone or your desktop PC, or other devices, including some of TOA's equipments. So SIP is often misconstrued as like a very low-level protocol. In fact, it's layer 7, which is the application layer of the OSI model. OSI model is the general conception of how the internet works, and SIP works on the application layer. Oftentimes, people, because of the name, Session Initiation Protocol, think it's on the session layer, which is layer 5, as you can see over here. But it actually works like your HTTP, which is how your browser works, and your SNP, which is the protocol used by email. And so, since SIP is an application layer protocol, it borrows a lot of structures with HTTP and SNMP. So, for example, how commands are sent and received in the servers and sent by clients or end devices It's very similar to how your email browser or your email application sends and receives commands. So what happens actually when you have, say, your Microsoft Outlook, whenever you send, you click a send button in your device, in the background, it's sending all these commands that were pre-programmed by the software developer, which these commands are actually SNMTP commands. In the same way, SIP does the same. So when you say dial a number, what happens when you dial the number or an extension in a SIP device is it sends these text-based instructions to the server or the other receiving and the other end user devices. As you can see here, the structure of SIP and its credentials is very similar to how email is. You have SIP, my account at toasip.com. That's just a sample of how an account is structured when it's sent as data to servers. So toasip.com, that is the domain name of the server, which is then translated to IP by domain name servers. That you can look that up and how that works. And my account is your username account that's associated with that domain. Likewise, when you're sending commands in the background, when the device sends commands and requests in the background, you have text-based commands like this: invite space my account toasip.com SIP /2.0. You'll see this a lot when you're looking at SIP server logs. Also, one thing to note is that SIP uses both client-server models and peer-to-peer networking structures, so they alternate between the other. When you're when you're registering to a server, which I'll show you how that works later, it adapts a client-to-server model with the server, the registry server. When it connects to another user device, it switches to peer-to-peer. It alternates. What are the components of SIP? So there's two major system devices that are in play in SIP as a system in general. There's user agents, which is the end user devices. TOA SIP products in particular are a type of, all of them are end user devices. TOA does not manufacture and provide SIP servers. And SIP servers is the actual mainframe computer on the network that services request from the individual user agents. So we'll go into detail on these two. User agents as clients. So user agents have two functionalities because, again, they switch between client server and peer-to-peer network architecture. So during the setup, when they're just registering or trying to contact the server, they will adapt a client server model. In that case, in that structure, your user agent, your device locally, is acting as a client at that point in time. In the later, okay, so here's a image diagram of how that works. It will send a request, and then it will get a response from the server with data that it requested. Now, when it switches to peer-to-peer, because it's peer-to-peer, of course, they will alternate between server and client. So there's a subset of functionality in your user agent that it will act as a server, especially when it's communicating directly with another user agent. So for a time when it's sending data, it will be a user server. And then when it's requesting data, it will be acting as a user client. So those two alternate between each other, and that's how peer-to-peer works. So SIP servers, they're the main hub that facilitates the communication and the transfer of addresses to the individual end users. So their SIP servers are used to resolve SIP users to the respective IP addresses. Just to note, one SIP user can have can be associated with multiple IP addresses. So that means multiple devices. So SIP has this feature, what that is called SIP forking, where it will ring multiple devices associated to your single user credential. And this is facilitated. This is one of the functions facilitated by the SIP server. Another function that they fulfill is to enforce and facilitate security. Finally, their proxy servers, that's a sub-functionality, which I'll discuss later, is what deals with this security issue. Generally, SIP servers are handled by IT departments, especially because it's under the umbrella of how they've implemented VoIP. So when you're installing SIP equipment, you really need to coordinate with your IP department. I can say this from experience that most of the problems that you're gonna deal with in setting up your SIP equipment is gonna be down to the IT related issues. To carry out the general task of the SIP servers, there is 3 sub-functionalities. I mentioned one of these earlier. These sub-functionalities may be implemented on different machines or all in one. One of these sub-functionalities is the register server. The main function of this is to register all users and the IPs associated to each individual user. So it sets a database of what the IPs tied to one particular user. It also obtains the IP addresses of the device that the user is logged in and registers under it, continually updates this database so that when a call is made, it's referred to later, and then there's a smooth transition of the setup of the session. And the second sub-functionality is the proxy server. So think of this like your lawyer or a secretary liaising with the outside world and is encapsulating and isolating you from all that nonsense, so that you only need to really receive what you need to bother with. So you're not exhausting unnecessary resources for your network. It also puts a security essentially like a firewall, so that people who are not allowed to contact you cannot contact you internally. Or if you have a SIP server extension that you do not want the outside world to be visible or to be accessed, then the access directly, then you can put that setting as block in the proxy server. The third functionality is the redirect server. So as opposed to the proxy server being your secretary dealing with all that calls and all that attempts to contact you, instead the redirect server is that lazy secretary that just sends you whatever comes your way and just pipes you out to you. This functionality also is responsible for the SIP forking I mentioned earlier. So any SIP server system has all these 3 functionalities that are working in tandem to facilitate a call. Let's look at how SIP works under the hood. For this, it's really helpful to understand how SIP works, so that when you're dealing with server activity logs, you can understand and troubleshoot what's going on. And also just to get a better appreciation of how SIP works as a whole. By the way, the previous the slide over here, you can see a sample of the SIP address or the SIP user credential that is being shown on the activity log. And the second one is a command that it was received by the server from one of the SIP devices that was trying to communicate with him. SIP is like, as I've said earlier, is like HTTP. So there's text-based commands that are being sent as data from the client to the server. And these commands accomplish certain tasks or request certain resources from the server or the other end user device. I would say that the first 3 commands here are the most important. Register is the command that's being used to request a registered process to be instantiated on the server. Say when you're installing a new device, in the background, after you've entered all the credentials, this register command is what is sent to the SIP server and what it responds to when it accommodates the register request. Invite is the command used to invite, of course, another end user to be in a call. Acknowledge is the handshake signal saying, I've received your session and we can start the session. So these three are the most important. You can refer to the other ones later on the slides, but they're not as much important. Another aspect of SIP, the other half of the commands, is the responses. I think a lot of you have seen that error 404 message on your browser when you try to enter a email ad or a website and you're not connected to the internet. So that error 404, this response code is very similar to that. This is the analogous version in SIP. These response codes are how the server or the receiving end user responds to you, and tells you that what you requested was received, being processed, or successful, depending on what command you sent. I'll not go into the individual details of this, but I think you'll get a better appreciation when I show you how the flow chart of the structure of SIP works. So here is a peer-to-peer activity going on. So first you have SIP phone A and another is SIP phone B. What we're trying to accomplish here is SIP phone A will try to establish a connection with SIP phone B, and then we'll see how SIP facilitates the peer-to-peer setup and tear down of the session. So first, SIP phone A will send an invite command to SIP user B. SIP B will receive that command and then will ring. And at the same time, we'll send a response code 100, which is the ringing response code, telling the SIP phone A that, okay, I'm ringing, I'm waiting for my user to pick me up. When it picks up, when it gets picked up, it will then send a response code 200 saying, okay, my device has already been picked up. This is just letting you know. When SIP phone A receives this, it will then send an acknowledge command to SIP phone B. The acknowledge command contains the parameters of the communication data type that is being established. If it's just voice, it will use RTP, which is real-time transfer protocol, which is how sound data is being sent from one device to another. When user B, when the call is finished and user B hangs up, the user B will send a by command to user A, and then it will respond saying 200, which means okay, and then everything is reset to its base point process. So this is how this gives you an idea of how these commands are working under the hood in SIP. This is very useful, especially when you're troubleshooting, to understand these, because this is what you will see and you will relate to when you're looking at the logs when you're installing systems. Okay, another one is when a SIP device, in this case a Cisco 186, is going to be registered to a SIP server, which is a register server. First, it will send a register command. The SIP server will respond saying, I'm trying to register you. And then the SIP server will start looking at its database. When it doesn't find the device that is asking for registration, it will send a 407 response saying, I need you to authenticate for me. the device trying to register will then respond with the register command, this time with the credentials that it has. The server will respond then to the device saying, I'm trying to register you. And when it's successful, it will send an OK signal. So this is how the register process works under the hood. You will see that this is very useful when you're trying to provision new devices onto an existing SIP server. Oftentimes, there will be a failure of the register command, more often than not because of the incorrect credentials. Or if your system doesn't receive a register command at all, then that means that most likely the connection to the server is non-existent. So you have to, again, go and coordinate that and ask the IP department. Finally, this is the most complex example I will tackle with. So here we have a SIP server, which in this case will be acting as a proxy server between two devices. First, the SIP, the end user A will try to call end user B. But since end user B is connected behind the proxy server, it's not directly accessible to user A. So when the invite request is sent to user B, it gets intercepted by the server. The server then it will respond that trying. And then if they need authentication, it will request for authentication. The user A will send an acknowledge to it and will provide information. And the server will then facilitate that connection to end user B. While it's trying to contact user B, it will send to user A saying, I'm trying. So when it's trying, user B will respond to the server, not to the user A, saying, I'm trying to ring. Then when it's picked up and received by the user at the other end, that acknowledged signal saying successful will be sent to the server, which it then forwards to user A. User A will send OK. User A will send OK to the server, and then we will send the OK signal to, or acknowledge. Sorry, I'm acknowledge to user A. After that, after user A receives that OK signal, which goes through the server, it then goes and sends an acknowledge command, again bypassed by the server or going through the server, and then is then transmitted to user B. Then and only then can the call be established. As you can see here, everything is being handled and passes through what's called the proxy server. So there's no direct interchange between the user A and user B, and everything goes to the proxy server. This is for security purposes. Only when the call is established does user A directly connect to user B. And then even after the call is finished and one hangs up, everything goes to the proxy server. So you see here says a bye, and then the server will send trying, while the server also sends that bye command to the other user B. When the user B responds saying, OK, I received your bye command, and then so the proxy server will then forward that to the user A. This is how the servers and the individual user devices interact with each other. There are more complex interchange that happens, but this is just to give you a short understanding of the interchange and the relationship between the servers and the individual devices. Since the SIP servers is mostly handled by the IT department, when you're installing new SIP devices, you're mostly going to deal with SIP registration and call testing. So again, you will need IP addressing, you need knowledge of subnetting, and ports and sockets. This is mostly for LAN. This is for everything actually, LAN and cloud-based SIP systems. When you're dealing with cloud-based systems, you will need to deal with, you will need understanding of public versus private addresses and how this feature called NAT traversal. This is how system that facilitates allowing your device, which is on the local private address, which has a local private address, being able to communicate with an external device that is not in the local network. That's how the package jumped from your local network onto the wider internet. There's two popular systems that are used for NAT traversal. One is the keep alive, and the other is the stun, which uses a separate, what's called a stun server. And since you are dealing with cloud-based systems, this is where you will encounter most of the time domains and domain names. And so you'll need to understand domain name resolution. Okay, so requirements when you're provisioning a SIP device. First, you need a SIP account provision on the SIP server. This is done mostly by IT departments, or if you're part of the system, part of the IT system, or it's under the same contract, then you'll have to provision that user account with the SIP server. So when you have this username and password, you'll need to enter this onto the SIP device. Now, oftentimes, I've seen this a lot, SIP devices are mostly local. So that means that they don't see the wider internet. They don't go to the cloud. In this scenario, it's more efficient to do away with domain names. And instead of using usernames, you have extensions instead. And instead of the IP addresses, or instead of the domain name, you use the IP address instead. So instead of having a SIP : my account at TOA SIP.com, this becomes SIP : 202, which is the extension number, at 192.168.1.150, which is the local address. This is the local address for your SIP server. Okay, finally, because there's transmission happening on the SIP domain, you need to understand TCP and UDP. So brief overview of TCP and UDP. This is the protocol, which is a low-level protocol on how that data on the packet level is transmitted and how it's verified. TCP has a error checking mechanism to the protocol, as opposed to UDP, which is often used for video streaming and other raw data broadcast applications. UDP does not have error checking, so it's much more. So yes, TLS is the encrypted version of TCP. So you'll need to get the port information for this. So again, as I said earlier, port is like your unit number, and your IP is your apartment address. So depending on the what department does it go, where the mail needs to go, you need that unit number. So the port is the analogous counterpart for that. Finally, if your SIP is used to set up systems involving video and file transfer, it's helpful to remember the respective protocols that the IT department has used for this. So this will be a useful thing in case you need to troubleshoot for this in the future. Let's look at how one can provision a end user device. For this example, I will use the NSPAT-MS, which is the SIP master station from TOA. To set up the the master station, you will need to navigate to, of course, the browser of the device and go to the account and basic menu. So for this account basic menu will show you the drop-down menus and the boxes you need to fill out with the SIP credentials that you have so that the device can register with a SIP server. The master station is able to handle 2 accounts, and you can also enable and disable this. You can also provide labels for it, but the most important things is the register name, username, and password. Oftentimes, this register name and username will be the same. So put your username onto these 2, and then you put in your password credentials for it. Now, since assuming that your device is local and your SIP server is also local, you put this on the server ID, server IP tab. You put in the server IP, and then you put the port number on based on the protocol that is used by the system. In this case, 5060. That's a port number for UDP. So 5060 is what we put in here. Registration timeout is the how long does the registration keep on refreshing. If you're using an outbound proxy server, you'll need to enter the IP or the domain name for that in the menu over here. And then finally, on the drop-down menu over here, it will ask you what protocol are you using, UDP or TCP or TLS, and you select that over there. Finally, if you have a if you're on the device that needs to go through the wider internet, you'll need NAT traversal for that. So you will need you need to specify what protocol are you using. Is it your regular stun server? Are you going to use a stun server, or are you going to use your the other version, which is a keep alive protocol instead of the stun? Assuming that you've inputted all this credential here, once the device is rebooted, it will automatically in the background instantiate those instructions that I showed you earlier. When this is received by the server, the communication and verification happens, and if it's successful, it will display that the registration is successful. Again, when you're dealing with setting up SIP devices, you're mostly just dealing with the registration part and the call part. Later, I will discuss what are the pitfalls of the registration and what causes issues, why registration often fails, and how can we diagnose that, and how can we isolate and zero in on where the problem is. Now, since SIP facilitates the call itself, the session, there's gonna be data interchange between devices. We're dealing with analog systems here being converted to digital data and then being sent over the network to the device that's receiving it. So there's a form of coding and decoding happen in the background. So this is accomplished using protocols called codecs. So this is the scheme or standard in which the device and the analog signals transfer your analog voice and your analog signal, audio signal, into a digital data that is able to be sent over the network. Now, there's a variation in codecs depending on the application. For telephony, because there's so much data that may be implemented or maybe moving through the network, because let's face it, audio requires a lot of information, data-wise. Your codec influences how the system can handle. It factors into how the system is able to handle the transmission of data. Ideally, you need something that's lightweight so that it doesn't overburden your network, but at the same time, it allows for intelligibility so that you can still understand each other. I think people have encountered issues with VoIP systems before, where something get some voice or audio gets garbled, and it turns out that that is caused by a corruption of the data packets that are being sent to the system. That sometimes is because of the codec. Now, codec is like your translation from analog to data. But in the data domain, people need to understand the same language. So every endpoint and every device needs to understand and have the same codec. There has to be a unanimity for codecs used for all devices. Otherwise, one device cannot understand the other. So there's a couple of popular codecs for both audio and video that is commonly used in SIP facilitated devices. G.711 is an older version, which only has a more narrower frequency range. So the sampling for that is much more narrower. And G.722, it's a much more recent codec. It uses a wider frequency range of audio, and it's much more intelligible than G711. As for video, more popular codecs, I think, is the H.264. The more recent one is H.265. The H.263 is an older one, which I've rarely seen being used. More often than not, H.264 and H.265 is more up to date in the present. So going back to the example of the master station, because the master station also uses features audio and video, it supports the respective codecs. And in this page over here on the advanced page of the setup, you will see that you can configure and enable or remove codecs which you would like to use. So this is important because you need, again, to specify and match the other codecs that are being used by associated devices. This is one of the pitfalls that I've seen in product support. Okay, assuming that you've done the user credentials and you've double checked it and the credentials you put into the device is correct, and you're still not having any luck with having your device registered, or in another case, yes, your device got registered, but that device is not communicating with the other devices that it's trying to call. There's no success in that. Well, for that to diagnose, I would say 99% of the time, activity logs of the server or your devices would be the best place to go, because these logs will show you the succession and progression of what I discussed earlier of how that command is being propagated and received by the individual servers and devices. And you can see successively what's happening. From that information, you can isolate and say, okay, my invite command is not being received by the server. What does that mean? Oh, I'm not actually connected to the network. That means there's something wrong with the actual connection itself. So you're not going in a wild goose chase trying to isolate and blindly try to fix issues that you may encounter in provisioning. This also works when, say, you provision a device and it's working, and all of a sudden it conks out. Here you will see in the logs how your device is malfunctioning. You can see, you can correlate this flow of instructions over here between the servers and the end user devices. You will see this in action in the logs. So that's why the log is very helpful. And this allows you to really be sharp and surgically precise in isolating issues that you may encounter with both provisioning and troubleshooting already existing installed and malfunctioning devices. So it helps in the process of elimination. And you can see where and what stage of the flow of commands does the issue come up. TOA is mostly dealing with end user devices. We have the SPAT line, which is the video and intercom series. We also have the SP11N, which allows for paging for the 9000, 900, 800, and BG series of amplifiers from TOA. If you have an existing N8000 system, this can be tied onto the SIP network using an N8000 SIP gateway. This is a software installed on a PC that acts as a gateway hub that allows your SIP network to communicate with N8000 devices. And finally, we have the IPA1 series, which is the upcoming TOA devices. These are PoE devices that allows for SIP functionality and SIP calls to and from speakers, and thus gives a wide range of functionalities before not available in the IP audio domain.